Yeah, road to 100% with destination varsity. We ended up saying we'll touch on simultaneous equations. We're not wasting any time. This is road to 100%. So let's just dive in deep to the simultaneous equation problem. So we ended up on 1.1.3. Let's go to 1.2 now, which literally says solve for x and y if 3x minus y equals 4 and x squared plus 2xy minus y squared equals minus 2. So you're solving for x and y concurrently. You're solving for them simultaneously. At varsity, they would say concurrently because they like using fancy terms. But simultaneously, concurrently, at the same time, those are just like similar terms. Okay, let's go straight to the problem at hand. It says 3x. By the way, you need to love mathematics for it to love you. Or maybe pretend to love it for it to love you. Okay, 3x minus y equals 4. That's your equation 1. Eh? And the equation 2 says x squared plus 2xy minus y squared equals minus 2. Equation 2. In this case, you look for simpler things because you're in an exam situation. You're trying to attain 100%. So it's easy to manipulate equation 1. Eh? So let's convert equation 1 to what? To equation 3. So we're transforming equation 1 into equation 3. In equation 1, you see that your x has a coefficient that is not 1. I mean, it's relatively easy to make what? Y the subject of this equation. So it'll be a matter of taking this here and this here. So it's like you're taking y on the other side to the other side and you're taking 4 to the other side. They call it transposing in high school. Okay, cool. So that means now our equation 3 will be y equals 3x minus 4. Sorry, minus 4. Why am I saying plus? It's minus 4, ne? Oh my gosh, let me start afresh. Minus 4. Yeah, that's your equation 3. Equation 3. Some people say equation 3. Those who can't pronounce 3. Equation 3. Okay. Let's then now, we now have 3 equations. Equation 1, equation 2, and equation 3. So equation 3 can be substituted in place of y in equation 2. Because you're trying to solve for x and y concurrently, right? So now the next step will be for you to substitute equation 3 wherever there is y in equation 2. You can't substitute back in equation 1 because things will just cancel out. You get what I'm saying? So you have to substitute in the equation that you didn't touch. If you manipulated equation 2 to equation 3, that means equation 3 should be substituted into equation 1. You get what I'm saying? So you can't play around with something that you've manipulated. You need to substitute in the equation that you didn't manipulate. Okay, cool. Let's go to the substitution part. Let me move this up a bit. So our equation 3 should be substituted in equation 2. And our equation 2 says x squared. It says x squared plus 2xy. But instead of y, what are we substituting? We're substituting what? Equation 3. So you literally, instead of y, you literally open your brackets and you plug in your y, which will literally be 3x minus 4. And then minus y squared. Instead of y, what are we plugging in instead of y? We're plugging what? 3x minus 4. So 3x minus 4 here. 3x minus 4 all squared, ne? And that is equivalent to what? It's equivalent to minus 2. Okay, cool. So now, what did I just do here? Maybe for someone who's marking your work, before you literally head to the substitution phase, maybe before you head into this segment here where you're literally substituting, maybe write sub equation 3 in equation 2. You get what I'm saying? Maybe write it somewhere here in this line over here so that it's easier to follow your logic, if you get what I'm saying. But since we all smart here, we'll just, omit that. But in your exam, do write that substitute equation 3 in equation 2. Okay, cool. Let's move this up a bit so that we have some space. And then do the math. Okay. So x squared, there's nothing that you can do with x squared at the moment. So let's write it as it is. Plus, then you just use you expand. You literally multiply what's outside with what's inside with what's outside. So it will be literally 6x squared here. And then 2 times minus 4, that will be minus 8x, ne? Minus 8x. I'm using my head, so I'm trying to see if I'm still smart. Okay, cool. Before maybe we complicate this further, let's just open solid brackets here. What is this thing telling you? If there is like 3x minus 4 squared, it literally says the same bracket has been multiplied twice. So it literally say the same thing can be replicated twice. 3x minus 4, 3x minus 4, ne? And then you close your brackets, equals minus 2. Let's see if there are any like terms, because we don't want to, waste our lives trying to, do things. There is x squared here, there is x squared. You can literally simplify that and group it to become 7x squared, And minus 8x, let's drop this as it is, minus solid bracket. So we literally expand the brackets. We kill the brackets by multiplying this with this and also multiplying this with that. Né? So 3x times 3x, that's 369x squared. Né? 9x squared. 3x times minus 4 minus 12x minus 12x. 4 minus 4 times 3, that's minus 12x again, minus 12x. Let's move our page a bit so we have some space. Then 4 times minus 4 times minus 4, that's positive 16. Positive 16. Itumele Nkune's jersey number. Positive 16. That's equivalent to minus 2. Okay, maybe let's minimize our page so we can see everything. Everything. Let's drop this again. Drop and bars. Drop this again. Let's drop the bars. Okay, cool. So you literally have to kill the solid bracket now. How are you gonna kill it? By multiplying inside with the negative sign. But before you do that, just know that this can be grouped into minus 24x, ne? Minus 24x. These are like terms. Yeah, these are like terms. Maybe let's just do that in a separate step. So it will be 9x squared minus 24 minus 24x plus 16 equals minus 2. Right? Okay. Now we can kill the solid bracket by doing what? By multiplying inside with the negative sign. So whenever there is a negative, there will be a positive. Whenever there is a positive, there will be a negative. Right? So that means now you'll have 7x squared minus 8x minus 9x squared plus 24x minus 16 equals minus 2. Okay, let's look for like terms now. You see this guy over here is similar to this guy over here, right? And also this guy over here is similar to this guy over here, right? Then you'll have to transpose this to this other side. So it will turn into plus 2. But let's not complicate things. Let's focus on the x's now. Not on the x's, like literal x's. The x we're solving now, eh? Okay, cool. Let's go move up our page. You shouldn't focus on your x's, hey? Okay. So it's literally says 7x squared minus, I'm trying to be serious again. 7x squared minus 9x squared, that will be minus 2x squared. Then minus 8x plus 24. That's like 24 minus 4, that's 20. So it's plus 16x minus 16. Let's take our 2 to the other side. Plus 2 equals 0, ne? Then it's literally be minus 2x squared plus 16x. Then minus 16 plus 2, that's like minus 14. Minus 14. That's minus 14. Let's move our page up a bit so we create a space for our problem at hand. And then at this point, you just want to simplify your quadratic equation as much as you possibly can, because this is in a form of ax squared plus bx plus c equals 0. At this point, some people can just use a quadratic formula, but I'm a fan of opening factors. Like, I just like opening factors because it literally opens your mind. When you open factors, when you look for factors, even your mind does get, because you get to learn lots of skills that become vital in the upcoming sections. Your inequalities, your graphs, your calculus, everything circulates around it. So the quadratic formula, I'd advise students to use it only if they are forced to use it. But if you can open factors, normalize opening factors because it literally opens your mind. So let's literally try and simplify our equation. Then you divide with minus 2, divide with minus 2, divide with minus 2, divide with minus 2. That will be 0. That will be 0. Ne? And then this will turn into what? This will turn into, I'm sure it will turn into plus 7, right? And also this will turn into minus 8, ne? So it will be minus 8x, ne? And this cancels with this, then you're left with x squared. So then the resulting equation will be x squared minus 8x plus 7 is equal to 0. Okay, let's move our page again. At this point, you can just open your brackets and look for factors. What are the factors of x? It's x and x, ne? X and x. What are the factors of 7? Such that when you add them or subtract them, they give you 8. Okay, how do you go about this? Is my last term positive? Yes, it is positive. What does it mean? My factors have similar signs. Which sign are they taking? The sign of the middle term. Is my middle term positive or negative? Negative. What does it mean? Both my factors are negative. What are factors of 7? It's 7 and 1. Yeah? You're done. You're literally done. Therefore, your x will be equals 7 or your x will be equals 1. But you're not done because they asked you to solve for x and y simultaneously. Ne? So you need now to solve for y again. Let's solve for y. How can we solve for y? We know our equation 3. Let's go back. Let's go up. In class, when I say up, it's more like I'm saying let's go up. Okay. So you can substitute your x values here in equation 3. Let's just take equation 3 down. So it's equation 3 is 3x minus 4. Let's write it here in red. 3x minus 4. That's your equation 3, ne? So substitute x values. Oh my god. In equation 3, ne? Never mind my handwriting. Hey, never mind my handwriting. I mean, yeah. I'm not my handwriting. You know those Twitter people that be like, I'm not my Twitter post. I am not my handwriting. I'm very, very cute than this handwriting. Okay, cool. So let's sub in in place of x, you put in 7. What are we getting? Let's just use our calculators to save time. So it'll be 3 times 7, that's 21 minus 4. I think it's 19. Oh my gosh. Maths. Hey! Maths is killing the youth. So it's 3 times 7 minus 4. Yeah, it's 17. So, okay, let's punch the calculator. Yeah, it should be 17. So that means now when you write your first bracket, you'll be like, when x is 7, y is what? Y is 17. That's your first bracket. And then your second bracket, you just plug in 1 in place of x. And then when x is 1, y is what? Minus 1. You know, those people who focus on tiny details, they'll be like, this order is not correct. You know, when they try to complicate things. But you get full marks if you write it like this. But for people, for the lack of a better word, but people who focus on tiny details, I just forgot the term. They would literally say, in your number line, we're done with the problem. This is the answer, né? I'm just going like an extra mile. So they would literally say, in your number line, let's say you were to draw a number line, there's 0 here. 0, 1, and 7 is further down the number line. Sorry, 7 is further down the number line, né? So that literally means this bracket here, or this coordinates, should come first when you're reporting your answers than the other coordinates. So they'll prefer presenting or writing their answers in this format, starting with the other coordinates. Then they'll be like 1, minus 1, and then they'll be like 7 and 17. But either way, these are the answers. I mean, it's just the same thing. But for logical senses, this is how maybe you should write it. For you to be fully present. It shows that you're fully present in your workings. To check your answers, take this x and y, substitute in equation 2 and see if you're getting minus 2. Also take this x and y, substitute in equation 2 and check if you're getting what? Minus 2. If you're not, that means you made some mistakes somewhere. Then you'll have to go back and double check, no? Because these are just free marks. I don't want to do long lectures. Next time when we meet again, we'll touch on the next section. I think that's more related to inequalities and those interesting special questions. They're so-called special questions. This marks the end of this lecture. Road to 100% destination versus Danko.